Okay, so this is going to be your lab for single and double replacement reactions. Now I'm going to step through this quickly, and you can go through the PowerPoint. You really don't need the PowerPoint, but it's useful to see what actually happens in the lab. So as you go through here, I'm going to post the lab file, which we're going to be working from for a second. Remember, these are things that provide chemical reactions, evidence of chemical reactions. A gas is produced, precipitate is formed, it gets hotter or colder. Okay, so as you go through, this is single replacement. You're going to be using your activity series on all of these, and you have this. There's some examples of single replacement reactions. We've already done those in class. Remember, in order for something to react, this metal has to be more active than this metal. If we're looking at my mouse, okay? So what we're gonna do is you go through and there's pictures of before and after. If there's no change, which I suggest you do the reactions first and then go look at it and see what happened. You can actually predict what will happen. Like in number 1, there's not gonna be any sort of reaction, so there's no change. Now, as you click through and go through, there's some videos for some of these. I gotta actually find the PowerPoint file. I'm waiting for Ms. Newby to get that to me so you can actually see the videos themselves. But in some of them, you're gonna have no reaction if everything's going to be aqueous after. There's a reaction for every single one of these, I believe. As you see, like in number 1, hint, there's bubbles formed. You need to write there's bubbles formed on your paper. Now, I'm going to go through and do 5 or 6 of these with y'all. On this one, there's no video file. I got to give you the PowerPoint. So this is what that looks like. So what we're going to be doing is we're going to be writing a balanced equation for every single one of these reactions if there's a reaction that actually occurs. Let me make sure it flipped. Okay, so stepping through a few of these reactions with you. So I'm going to do most of it with you. This is also really good practice for your upcoming test over chemical reactions. Okay. So I'm going to work on the single replacement. I'm going to work 1 through 5 and number 8. Okay, so number 1, it says we have solid zinc and we're mixing it with sodium chloride. Okay, so we're going to write a balanced equation for that one. Okay, so zinc is Zn. Okay, and sodium chloride is Na with a +1 charge, Cl with a -1 charge. No need to crisscross because they're equal and opposite charges. Now we're going to look at our activity series. Our activity series, where's my activity series paper? Okay. Our activity series says that zinc is right here and sodium is up here. Oops, sorry, zinc is right here and sodium's right here. So there's not going to be any reaction because it's got to be a more active metal to kick it out. So we just write no reaction. Okay, number 2. It says we're going to do zinc and magnesium nitrate. So magnesium's Mg with the +2 charge. Nitrate is NO3 with a -1 charge. Now we're going to crisscross just like that. Now, we're going to look at our activity series. Zinc and magnesium. Zinc is not above magnesium, so there's going to be no reaction. Okay, so that's why we spent so much time on activity series. Okay, let's look at number 3. So it says we're going to react zinc with about 5 milliliters of copper 2 sulfate. So copper 2 is C with a +2 charge. Sulfate is SO4 with a -2 charge. No need to crisscross because they're equal and opposites. Now I'm going to consult my activity series, just like I did before. Is zinc higher up than copper? Well, zinc is right here, and copper is down here. Okay, so it will replace it. Okay, so we're going to flip. We're going to switch those out, and we get zinc always has a +2 charge, sulfate -2 charge, no need to crisscross because they're equal and opposites, and we're going to kick out the copper. Okay, and everything should be balanced because there's one of each. Okay, let's look at number 4. Okay, it says we're going to take zinc and we're going to react it with silver nitrate. So zinc plus silver is +1 charge, nitrate is NO3 with a -1 charge. And we're going to look at our activity series. And zinc is right here, and silver is down towards the bottom. So it's going to replace it. So they're going to kick each other out, like that. And we get zinc with a +2 charge. Nitrate is NO3 with a -1 charge. You have to crisscross. And then silver goes on the outside, like that. Now we got to balance this. So we got 2 nitrates on this side. I need 2 nitrates on this side. 2 AGs here, 2 AGs here, and it's going to be balanced. Let me check and see what other. Let's look at number 8, and then you can do the rest from here. It should be relatively easy. So on number 8, it said we're going to do solid copper plus 5 milliliters of silver nitrate solution. So copper is Cu. Silver nitrate is Ag with a +1 charge. Sorry. Ag with a +1 charge. NO3 is a -1 charge. They're equal and opposite, so we don't have to crisscross. Now we're going to look at our activity series. Is copper above silver? Oh, wrong paper, sorry. Is copper above silver? Copper is right here and silver is right here. So it's going to kick it out. So they're going to actually react with one another. Okay, so we're going to use copper to nitrate. Sorry, I keep hitting that. Nitrate's going to be NO3 with a -1 charge, and we crisscross. And we're going to kick out the silver, like that. Now, we're going to balance this. You got 2 nitrates on this side. I need 2 nitrates on this side. 2 AGs, 2 AGs, and it should be balanced. So for 5, 6, 7, 9, and 10, you should be able to do those by yourselves without even looking at the PowerPoint, to be honest with you. Okay, let me adjust my camera a little bit because I keep hitting it. Okay, now let's go on to double replacement. So in double replacement reactions, you have to make sure that you use your solubility rules. Now, whenever we're doing this in the lab, you're going to see things that actually happen. It's kind of hard to see just from pictures, so I get that. So let's look at number 1. It says sodium carbonate. So sodium is Na with a +1 charge. Carbonate, CO3 with a -2 charge. Okay, reacts with hydrochloric acid. So hydrochloric acid is HCl. Okay, so this is a double replacement reaction. So we're going to take the outer 2 ions and put them together. So Na with a +1 charge, Cl with a -1 charge. And I'm going to take the inner 2 ions and put them together. Okay, so I get H and a CO3. Now, watch this. Carbonic acid is H2CO3. So whenever you break that down, it always becomes liquid water and carbon dioxide gas. Okay? And that's why you get bubbles. Okay? So our actual reaction, complete reaction, looks like this. Now, we're going to balance. 2 NAs, I need 2 NAs, 2 CLs, 2 CLs. We got to get 2 CLs on this side, 2 H's, 2 H's, and CO3, CO3, so it's balanced. So that's why I'm doing these with you, because you haven't seen that before. Okay, number 2. We're going to take sodium hydroxide, which is NaOH, +1 charge, -1 charge, and I'm reacting it with hydrochloric acid. So this is going to be an acid-base reaction. Remember, an acid-base reaction always produces a salt and water. Okay, so I'm going to take the outer 2 ions and put them together. And I'm going to take the H and the OH and put it together. So you get water out of it. And it should be balanced. You can write this as HOH if you want to. Now, one thing you didn't do is we got to go through and do the solubility rules. Okay, so for number 1, let's go back and do that one. Your solubility rules. All carbonates are soluble except for compounds containing NH4 in group 1. Well, sodium is in group 1, so we write AQ next to it. Hydrochloric acid, all compounds containing chloride are soluble except for silver, mercury, lead, so this is soluble. NaCl, all compounds containing chloride are soluble except for silver, mercury, lead. And then you already have your states on that one. Rules for hydroxides. All hydroxides are insoluble except for group 1, calcium, strontium, barium. Sodium falls into that exception, so it's soluble. Hydrochloric acid is soluble. All compounds containing chloride are soluble except for silver, mercury, lead, and we're going to form liquid water out of that. Okay, let's look at let's do number 4. Okay, it says we're going to mix silver nitrate. Okay, so silver is Ag with a +1 charge. Nitrate's NO3 with a -1 charge. Plus, we're going to calcium chloride. So calcium is Ca +2. Chloride is Cl -1. And we're going to crisscross. Okay, so when we do double replacement reactions, we're going to take the outer 2 ions and put them together. So this is Ag with a +1 charge, Cl with a -1 charge, plus calcium and nitrate. Ca has a +2 charge, NO3 has a -1 charge. So we crisscross. Okay, we're going to balance it. So when we balance, you got 2 chlorides here. We need 2 on this side, 2 Ags, 2 Ags, 2 NO3s, 2 NO3s. It's going to be balanced. Let's look at number 7. Let's look at number 7. Actually, number 7 is very similar to number 1. Let's look at, let's look at 7. Let's do 7 together. Number 7 says we're going to take a small amount of calcium carbonate. So calcium is Ca with a +2 charge. Carbonate is CO3 with a -2 charge. I didn't do my states on this other one. Let's go ahead and do our states on this one. I keep forgetting to do that. Sorry, guys. Okay, all nitrates are soluble, so you write AQ. All chlorides are soluble except for silver, mercury, lead, so you write AQ. All chlorides are soluble except for silver, mercury, lead. Ag is silver, so you write S. It's insoluble. And all nitrates are soluble, so you write AQ. Okay, number 7. We're going to take calcium carbonate, and we're reacting it with hydrochloric acid. So hydrochloric acid is HCl. Okay, we're going to do our double replacement reaction. We're going to put the outer 2 ions and put them together, Ca, Cl. Calcium has a +2 charge, chlorine has a -1 charge, and we crisscross. And we're going to take this and put it together with this. Hydrogen has a +1 charge, carbonate has a -2 charge. So it looks like that. Now, when you get this carbonic acid going on, it's always going to break down to water and carbon dioxide. Okay, so you're going to see some sort of bubbles going on. Now we're going to balance this thing. You got 2 Cls on this side. We need 2 Cls on this side. 2 H's, 2 H's, 1 CO3, 1 CO3. Should be balanced from there. Now we're going to go do our states. Okay, all compounds containing CO3 are insoluble except for NH4 in group 1. Calcium is in group 2, so this is solid. HCl is aqueous. Calcium chloride, all chlorides are soluble except for silver, mercury, lead. So it's AQ. And let's look at, I'll let y'all do 8 on your own. Let's look at number 10. We'll do number 10 together. And the rest you can do for your own. Okay, number 10, it says we're going to mix sodium chloride, so NaCl, +1, -1 charge, and I'm reacting it with silver nitrate, Ag, +1 charge, nitrate, NO3, -1 charge. Okay, we're going to take the outer 2 ions and put them together. Na, +1, NO3, -1, and Ag and Cl. Okay, we're getting those from our periodic table or our ion chart. Okay, so there was no need to crisscross because they're equal and opposites. So we're going to balance. It's all balanced. It's ones across. Okay, now we're going to do our states. Sodium chloride is soluble. All chlorides are soluble except for silver, mercury, lead. All nitrates are soluble. All nitrates are soluble. All chlorides are soluble except for silver, mercury, lead. So we write S. Let's go back up and do number 5. Let's do number 5 together, and then that's the last one we're doing. Okay, so number 5, it says we're going to mix lead to nitrate. So Pb with a +2 charge, nitrate is NO3 with a -1 charge. We crisscross. And I'm going to react it with potassium iodide. Potassium is K with a +1 charge. Iodide is I with a -1 charge. No need to crisscross because they're equal and opposites. We're going to take the outer 2 ions and put them together. And we're going to crisscross. And we're going to take the inner 2 ions and put them together. Like that. Okay? Potassium has a +1 charge. Nitrate has a -1 charge. Okay? So, balancing. 2 I's. 2 I's, 2 K's, 2 K's, 2 NO3s, 2 NO3s, 1 PB, 1 PB, it's balanced. Now we're going to go do our states. All nitrates are soluble. All compounds containing I are soluble except for silver, mercury, lead, so this is soluble. All compounds containing I are soluble except for silver, mercury, lead, so this is solid. And all compounds containing NO3 are soluble. So I want to take a second and actually look at this one because, let me pull it up, this is number 5. So this is actually a really cool one that you'll notice. So if you see the precipitate that's formed in this case with the lead iodide, it's yellow, okay? So you do see some kind of cool stuff happen in lab. Unfortunately, we don't get to see this real time, but hopefully this video was helpful, and if you need help, feel free to reach out. Thanks, bye.